cost applications. These are special type of cost applications. So again, it has to do with looking at sort of the logistics of cost for like a store or something, or company. So you have to get the item. You have to get the item shipped to you. You put the item on display, but not all of them. Some of them you keep back in storage. And so it has all those costs. So again, hopefully you've looked at the MyLab videos where they talk about it in detail. I am, again, just doing a couple more examples for you, so you see a few more examples if you want them. And these are sort of how I word my examples, too, on the test and quizzes. All right, so inventory costs. I've got an appliance store that expects to sell 2,400 microwaves in a year. It's always based on a year. Each microwave costs the store $120. So again, that's the price of the microwave from the manufacturer. They order the microwaves from the microwave manufacturer to put in their store. All right, each microwave costs them $120. That's the baseline cost. There is a charge, fixed charge, I mean it's the same every time, of $48 per order. So whether they order 10 microwaves or 20 microwaves, there's an ordering fee of $48 every time. Again, they're basing it in sort of an averages for taking up storage space, security, and other things. They estimate that it costs the store $9 to store the microwave, store a single microwave for a year, right, for it to be in storage. And so one microwave costs them $9 to store. The store orders the same number of microwaves in each order. The storage cost is computed based on averages. Again, it's always based on averages in stock during the year. All right, so the setup. First of all, the X value is always the number of items per order per shipment. All right, so in this case, it's the number, X is the number, the variable is the number of microwaves per order or shipment, however you want to word that. Again, they're not going to get them all at once, although they could, but that wouldn't probably be their optimum value. N is your total for the year, all right? You're going to order a little bit at a time, but you're going to get total. Well, their total would meet their demand of 2,400 microwaves, so that's their total. All right, the IC stands for inventory cost function. So again, I'm going to write it out in words. So again, what it is, there's three costs. There's the cost to order, the cost to store, and the cost to purchase. So there's the order cost plus the storage cost plus the purchasing cost. And I put them in that order because purchasing cost is always the constant. So that's why it's at the end. All right, order and cost come from, well, you have the number of orders. So we want 2,400 microwaves. We're going to ship X of them at a time, right? So if we shipped them 10 at a time, you would take your 2,400 and break it up by 10. So 2,400 divided by 10. And so the ordering cost is always your total, 2,400 divided by X, times the cost for orders. So that's how many, this is the number of orders, and then it costs them 48 for each one of those. All right, so that's the ordering cost. Total items divided by X, that's the number of orders per year, and then that's the cost per order. All right, that's where those numbers come from. I'm going to erase that because I don't want that in my next lines. All right, so there's the ordering cost. The storage cost then, and the storage cost is based on averages. The average, again, is a little more complicated. You just kind of have to memorize it. The average means, on average, you take the number of items per order and divide by 2. All right, so that's the X divided by 2, and then the storage cost, which is 9. So this is the average in storage. And again, the reason why that is has to do with, again, it's a fairly complex idea, but it has to do with averages. It's based on averages. So on average, you have X items you ordered. Half of those will be in storage. All right? And then that's your storage cost per item. $9 for the store, right? Store each one of the microwaves. So on average, you have X divided by 2 of them in storage, and each one of those costs $9 to store. All right, the last one's the purchasing cost. Well, we're going to order 2,400 microwaves total, and each one of them costs the store $120. All right, that's the storage cost. All right, so that's always a big constant at the end. Number of items times the storage cost. All right, so there is the cost based on inventories. right? How I set up my cost equation. And then to simplify this, well, let's just multiply some stuff out. So 48 times 2400, that multiplies out to a really big number, and it's always going to be a really big number divided by x. This should be a small number times x, a smaller number. In this case, it's 9 divided by 2, so you get 4.5. And then the purchasing cost is often a very large number, and it is 288,000. All right, so there's my inventory cost. That's what we want to optimize. We want to minimize this inventory cost. All right, so this is what we want to minimize. It's way down here where it's used calculus to determine the number of microwaves that should be included in each order, number of orders that should be placed to minimize inventory cost, verified as. All right, so this is what we want to find. Number of microwaves, how many orders, and our verification. All right, so I'm going to do my work up here. So we want to minimize. The understood domain for inventory cost. It's not open because they're only going to order maximum 2,400. So there's two domains that I will accept. Either you can ship one at a time up to all of them. All right, all of them would be all 2,400 shipped at once. You could do that. You could just do one at a time. Wouldn't be very economical, but you could. Or you could ship them all at once. Again, probably won't want to do that because of storage fees, but you could. Or another acceptable one would be 0 up to the maximum. All right, so you could either have it closed, 1 to 2,400, or open. You can't ship 0, right? You have to ship something, so that's why it doesn't include 0. And then you're never going to ship all of them at once, right? So somewhere between all of them and none of them should be your optimum value. And you can either do open or close. One of those two, those are it. Those are the two domains that are acceptable. Either one at a time in all of them and anything in between, or 0 to all of them, but not including 0 because you can't, and not including shipping all of them. So open or close. That means when you test it, you can test it either way. Alright, so there's the domains where I'm going to find my optimum value. So step 1, find my criticals, find my derivative and set it equal to 0. So when I find my derivative, I'm going to move it up here, make it a negative exponent. So -1 times that really big number is negative that really big number. X to the -2 plus the 450, and then the constant zeros away. And it's always going to end up being this way. It's going to be a big negative number, x to the -2nd, plus a smaller number. And that's it. That's always going to be what's happening. Find the critical values by setting that equal to 0. When I set that equal to 0, I'm going to rewrite that as a positive square down the bottom. Move that negative fraction over here to make it positive. And then multiply both sides by the x squared. Divide by the 4.5. And so that comes out 25600 equals x squared. We take the square root of that. Again, usually when we take the square root, it's plus or minus, but in this case, on microwaves, I don't want negative, so I'm going to pick the positive version of it. And so it comes out 160. Alright, so my guess is that's how many microwaves we want to ship in each order. So that's the x value. That's this one. Number of microwaves per order, 160. They want to ship 160 microwaves, right, each time they place an order. All right, well then how many orders do they have to place, right? They want 20, remember, they want a total of 2,400 microwaves. Well, how many 160s do they need to get shipped to them throughout the year so they get all their microwaves? Well, you take your total, your 2,400, divide by your 160, and so that comes out 15 orders per year. So 15 times they have to ship 160 microwaves to them. Alright, now the last step is to, well, you should always make sure that your answer is true, right? I put down a true statement, not a false statement. And so the test, the verification, and you can do either one depending on your domain. If you did the closed domain, you can set up the closed domain case. I prefer the open domain because I think it's the easier test. But either one's fine. This one, remember, if you're doing the close, you take your inventory cost, plug in 1, inventory cost, plug in your 2400, inventory cost, plug in your 160, and this one should come out the smallest, and you should show your numbers that they are. I prefer the open case because I think the second derivative is really easy to find. Alright, the second derivative is just that really big negative number times negative 2. That zeroes out, and so it's going to come out to whatever that is times 2. And so that comes out 230,400 x to the negative 3. When I plug in my 160, that's going to come out positive, right? If I get a positive number, I get a positive number out. That tells me it's concave up at the critical. So, yep, it's the maximum. Alright, the shape comes out concave up at the one critical value, and so it checks and it verifies that that does give me my optimum value. Alright, I'm going to do one more example of inventory cost, just to give you another example, second one, in case you want to see a second one done. Inventory cost is one of those things you'll see it on the quiz and you'll see it on the test. You have to be able to do an inventory cost equation where you find it, set it up, solve it using calculus, verify it using one of your tests. Alright, we'll stop there. We'll do the very last example in the next video.